Hi, and welcome back to this section on list and dict comprehensions and generator expressions. What are we going to learn in this section? We're going to start by taking a look at list comprehensions, which are an alternative to the for statement in the form of a single expression. Then we're going to take a look at dict comprehensions, which, as the name suggests, are like list comprehensions, but then using dicts, so they're an expression to create a dict in a single expression. Then we're going to move on to generator expressions, again closely related to list comprehensions, but this time built around generators, which allows you to implement lazy evaluation with them, right, which we've met in the previous section. And finally, we're going to take a look at nested comprehensions, so how you can implement loops within loops using list and dict comprehensions or generator expressions. But let's start with the video, list comprehensions, processing a list in a single expression. In this video, we're first going to cover the difference between statements and expressions in Python. And then we're going to consider the list comprehension, which is an expression, and it's an expression that is in a sense an alternative to the for statement. A statement in Python is an instruction to the Python interpreter. It's a way to tell Python to do something. And a for loop is, for example, a statement. A while loop is a statement. A def or a class, they are all statements. And you can recognize a statement because it doesn't evaluate to anything. They are instructions to do something, instructions to execute something, but they don't give you a return value in and of themselves. And statements are, in pure functional programming, not used. Practically speaking, if you use a reasonable mix of procedural and functional programming, you will use some statements, but in functional programming, the idea is to use statements as little as possible. Then we have expressions, and an expression is easy to recognize because it is anything that evaluates to something. So a very simple expression is 10 plus 10, right? That would evaluate to 20, but also function calls are expressions because they evaluate to their return value. And expressions are used heavily in functional programming. And a list comprehension is essentially an expression that serves, or that can serve in many cases, as an alternative to a for statement. Now, so let's take a look at how we can implement list comprehensions in real Python code. And let's start with a very simple for loop. So what we're going to do is we're going to import the square root function, and then we're going to write a for loop that for the numbers 0, 2 and including 4 prints out the square root of these numbers. Nothing special. So this is the kind of for loop that we all know and that we're familiar with. And this is a statement, right? We're using a for statement here. Let's see how we can implement this exact same behavior using a list comprehension. And you will see that it's very elegant. We start by indicating with square brackets that we're going to talk about a list. And then in the list, we simply put the same for loop that we had above. For I in range 5. Then rather than putting what we want to do with the I after the for loop, we put the expression before. So we say square root of I for I in range 5. And this, if I execute this, you see it will give a list with these square root numbers. So here the behavior is slightly different because above in the for loop we printed out the numbers. Here we create a list of the numbers. But we can get the exact same behavior by simply adding a print statement in the expression, which is allowed, right? Because print is a function and function calls are expressions. And if I execute this, we get the exact same behavior that we got above. So this is a basic list comprehension, a very simple list comprehension. Now let's take a look at a slightly more complicated scenario in which we want to filter the elements of a list. Let's consider first a normal for loop that skips all odd numbers, right? So we want to filter out all the odd numbers. Well, what we could do is we say for I in range, let's say 5 again, and then we print out these numbers. If I run this, we get 0, 2 and including 4. Now, how can we do that? How can we filter out the odd numbers? We can say if I modulo 2, so if the remainder of I modulo 2 is not 0, continue. Right, so the continue statement will filter out all the odd numbers. And we see actually, point to note that here we are using two statements. We have a for statement, and then later we have an if statement, and we're actually also using a continue statement, right? So there are statements all over the place. So how can we implement this with a single expression? Well, we can, again, using list comprehension. We can say, okay, print I, for example, right? If we want to print it out, for I in range 5. If I execute this, we simply get the number 0, 2 and including 4. But then I can say, okay, if I modulo 2. So what I'm saying here, if not I modulo 2. So what I'm saying here, only if the remainder of I modulo 2 is not equal to 0, right? So only if it's an even number, then we print out the I for the I in range 5. Right? So we emulate the exact same behavior that we got above with our for loop, but we can do it in a single, very elegant, in my opinion, expression. Now, so list comprehensions are very powerful. They allow you to do a lot of things. But one thing that you cannot very easily do is break. So and breaking is important, right? Especially if you're working with generators that are infinite. So let's consider here we have our Fibonacci generator that we've seen before. So let's consider a for loop that loops over this function. And what we want is we want to break if we encounter a number larger than 10. So if we would do this for I in Fibonacci print I, we would enter an infinite loop, right? Because the Fibonacci generator is infinite. So we need to build in some kind of stop criterion. So what we can say, okay, if I is larger than 10, break. And then if I execute this, we will get the Fibonacci numbers that are smaller than 10. Now, can we implement this behavior with the list comprehension? And this is the question. And the simple answer is no, that we cannot do that. And that is quite a big limitation, I think, of list comprehensions. Now, so for example, you might think, just to illustrate what is actually not a good solution, you might say, okay, we do I for I in Fibonacci if I is smaller or equal than 10, right? So we specify we only want the numbers that are smaller or equal than 10, and then we loop through the I and we capture them here. However, if I execute this, you will see that Python will never return. We enter an infinite loop. Why? Because we are not breaking when we encounter a number that is larger than 10. The only thing that we're doing is skipping those numbers. And in the meanwhile, our Fibonacci generator keeps churning away in the background ad infinitum. So that is something to keep in mind if you're working with list comprehensions. We will see another video using a generator expression that you can break generator expressions, even though also in that case, it is not, in my opinion, very elegant, but then at least it's possible. But we will see that later.